Okay, hey everybody. Um, Natural logs. Now, natural logs is kind of cool. It's very natural. So we'll get into it. But first, this is a good way to start work. Let's cancel some work. That's nicer. But then let's give ourselves some room because C and D are actually kind of interesting warm up. So let's spend our time on those instead of those simple basic ones up there. The intent is for you to try to do these. These are a little bit on the trickier side. So hit pause and try to do them. Go. Okay, I'll come back. Hopefully you're looking at this one and saying, I could do the log thing. This looks weird. The square root whole thing. Well, how did I do that? But hopefully you can recognize this as being, well, that's the same as the whole thing to the 1/2 power. Then I got the whole power to a power rule. So really this right side of the equation is the same as 4 to the x plus 3 um, to the 1/2 power. And that's the same as 4 to the x over 2 plus 3 over 2 power. Okay, well I can make 16 be 4 squared. So if that's 4 squared to the x equals 4 to the x over 2 plus 3 over 2. Now I got the same base on both sides. I can still use these old techniques for solving. I don't need to do the log of both sides all the time, etc., etc. So anyway, 2x equals x over 2 plus 3 over 2. Oh, fractions. When you work that through, I believe you get x equals 1. At least that's what I had the record of. Now, is that going to cause any problems? Sure. There's no logs going on here. This is an exponential. No worries. Okay, over here. Can I get these two to the same base? Well, I might first think, well, 1/8 is 1/2 cubed. However, I'll put it in red. Careful. Cuidado. Base must be greater than 1 in order. This is an inequality in here, so I got to be careful of this whole base greater than 1 thing. Otherwise, it's going to flip the direction around from what I'm used to. So really, what I should be 1/2 should turn into 2 to the negative 1 to the x greater than or equal to. What is 1/8? 2 to the negative third. 4 plus x. Power to a power rule. 2 to the negative x greater than or equal to. I don't need to rewrite that. You guys have done this a while. You can see that negative x has to be greater than or equal to negative 3 times 4 plus x. And then, what is that? Negative 12 minus 3x. Solve that thing and put the 3x, stupid thing. Put the 3x on the other side. Anyway, you'll end up getting 2x greater than or equal to, what is it, negative 12. And then x greater than or equal to negative 8. No, wait. Why did I write negative 16? Negative 12. X greater than or equal to negative 6. And that should work. I would take the time to test it out, but it's a video and you guys are in a hurry. So test it out on your own. See if it works. See if when you plug in negative 6 up here, if it seems to create the equals, and why it would make sense if x is greater than the negative 6, that this would end up being true. Now, E. Notice if you look on the TI-84 at least, right below the log button, which is next to 7, you'll have a natural log button right next to 4. And if you do the second function, see how it has 10 to the x and then e to the x power? So e is very closely related to this ln thing, whatever that is. And so to explore this a little bit, do e to the 1 power. Now I would tell you on the 34, I'll say, I think it's under the log button when you do second log, and you'll see a menu of choices. It's somewhere in there. I have to run upstairs to get my 34, and I'm too lazy for that. So you search for it on your own. But anyway, E and natural log will be really close to each other on the calculators and where those buttons are. Very closely related. E to the 1 power should get you to 2.718. What? I have 281 written down. I think that should be right. Now this is very much a magic number. It's a very cool magic number that appears all over the place in calculus and nature, and you'll be using a lot of it as you move through pre-cal and calculus. Why? I don't know. It's magic. It's like pi. It's actually even cooler than pi. Um, so this is a really cool number to know e, the natural log base. And so when you say, okay, fine, if I have y to the 2.718 blah, 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 raised to the e power, that's going to be a growth function, right? And of course, that would be a decay. So I can have growth and decay functions using base e, just like I did with any exponentials from last year. And this could also be written as y equals e to the negative x. See this e, 1 over e to the x power? Do you understand why that would be e to the negative x? That'll happen. We'll be doing that as we get into word problems especially. There are definitely decay functions that happen like this, and it's just a negative power will make it into a decay. The other thing to note is the natural log of x is the same as log base e of x. That's all it's doing. Is it's log base 2.718. That's all the natural log is. Okay, write in exponential form and find values. Okay, well, fine. If I say this is base e here, well, then all that means is e to the y power is equal to 13. Okay. Well, what should I do with that? I don't know if that helps me very much. Can I instead use my change of base formula? I could take the log of both sides here. I could take the log of that side, and I could take the log of that side. Or I could say, I remember the change of base formula. I'll go straight at it. This is equal to the log base 10 of 13 over the log base 10 of e, whatever that is. Yeah, try it both ways. I mean, of course, when you do this, you get to the same thing. Because remember, log on both sides, our change of base formula popped right out. In both cases, you get 2.565 as far as I know, 2.565. Okay, so bottom line, working with natural log is no different than any other log. It has the same properties. It's just some magic number. Same deal here. Now, before I solve f, don't forget, I really should get the log all by itself, so I should divide by 8. And then the natural log of x is equal to, what is it? Whatever that is. I didn't do this last year, so I don't have the decimal written down, but 2.14 divided by 8. 0.2675. Now, how can I do this? Can I map this and say e to the 0.2675 is equal to x? Yeah, that'll work. Okay. We'll go through all the basics properties, but this is really no different than working with log base 10s or log base 3s that we were working with. Condense it? Sure. Don't forget, a log is a power. Power belongs up there when we condense, so do that first. So this would be the same as natural log of 10 to the third over 8. Okay, easy enough. Let's do this one. This is a power. So then I'll go up here. Everything else is pretty normal, right? So that's the natural log of, well, put a bracket around it, 40 times 1/2 squared times x. Okay, well, 1/2 squared is 1/4, so that'd be the natural log of, stupid thing, 10x. Okay, this would be a nice quick lesson, actually. I didn't realize how quick this would be. All right, so let's go through the solving process. I don't know if I'll do k. It's all the same as, it's just like review of all the solving processes. First, let's get e to the 4x all by itself. And let's see, 15 plus 12, that's 27 divided by 3. So that'd be 9. Okay, Now, can I take the log of both sides, just like the natural log of both sides? Now, the reason you do this, and the reason I'm saying this, if you remember, is like, what is the log base 10 of 10 to the third power? Well, that's 3, right? Because the log base 10, as long as the base and the log and the base and the exponential are the same power, they kind of cancel each other out. Natural log is log base e, and if you, actually I'll rewrite it that way. Again, I'll write it as log base e of e to the 4x power equals, well, I'll write it as log base e on this side too, log base e of 9. Because, so, when I do log base e of e to the 4x, well, guess what? 4x equals, there's no reason to, I'll just write natural log of 9. So x is equal to the natural log of 9 divided by 4. And you can type it straight in your calculator. So, that's the easiest way to do that. Just type in your calculator. And whatever that decimal is, that's the answer. Okay. Solving this the same as any kind of other kind of inequality, so just go with it. I think we'll keep this video short and sweet. Hopefully that's good. See you guys.